For a straight line motion of a particle, the displacement of a particle as a function of time is given as x is equal to 16t minus 2t square. We need to find out the displacement of the particle after 2 and 6 seconds. So the first part is quite easy. We need to just put in the values of time to get the displacement at 2 seconds is equal to 32 minus 8, that is equal to 24 meters. The displacement after 6 seconds again comes out to be 24 meters after substituting the values. So the answer for the first part is quite straight. Now for the second part, while finding the distance travelled by the particle till t is equal to 2 seconds and t is equal to 6 seconds, what we need to keep in mind is that distance is not always equal to the displacement of the particle, because if in rectilinear motion, if the object's velocity becomes 0, suppose it is travelling from here to this side and its velocity becomes 0 at this point and it returns back. So from this point to this point, the distance travelled by the particle is this, but its displacement is only this. So if the velocity of the particle becomes 0 during the path, then the displacement is not equal to the distance travelled. So now let us check that when is the velocity of the particle becoming 0. To get the equation of velocity as a function of time, we differentiate the displacement equation to get 16 minus 4t. Velocity becomes 0 at t is equal to 4 seconds. So for finding the first part, there is no problem that distance travelled after 2 seconds. Distance travelled after 2 seconds will be equal to the displacement after 2 seconds, that is equal to 2 meters. Distance at t is equal to 2 seconds is equal to displacement after 2 seconds, that is 24 meters. Now for the second part, we need to find out the distance travelled by the particle after 6 seconds. We find that at t is equal to 4 seconds, the velocity of the particle is becoming 0. That is, velocity of the particle becoming 0 means that the object changes its direction. So from t is equal to 0 to t is equal to 4 seconds, it has travelled. Let us check. The displacement at t is equal to 4 seconds was 64 minus 32, that is equal to 32 meters. It travelled 32 meters. Displacement at t is equal to 2 seconds was 24 meters. T is equal to 2 seconds, object was here. Now t is equal to 6 seconds, it is again here because the displacement is 24 meters. So t is equal to 6 seconds, again the particle is here. T is equal to 4 seconds, the object is here. So we need to find out the distance travelled by the particle in 6 seconds. So the object goes from here to here and it returns back here. So the distance travelled is 32 plus 32 minus 24, this is 8 meters. So the distance travelled by the particle in 6 seconds is 32 meters plus 8 meters, that is equal to 40 meters. So the distance travelled by the particle in 6 seconds is 40 meters. The distance travelled by the particle in 2 seconds is 24 meters, and the displacement of the particle in 2 and 6 seconds is both 24 meters.